In this video, we're going to talk a little bit about changes in data and comparing data sets. So a couple of questions we might be interested in are, does data change over time? Does an entire distribution of values change over time? Or does an entire distribution change if an input is changed a little bit? So we're going to see how things change if we start mixing it up. And we're also going to talk about comparing different data sets in this video a little bit. So we might be interested in, for example, a broken line graph. So data points are graphed and connected with line segments, and this is used with continuous data, at least on the input variable, it's continuous data. And points on the line segment should be approximations of actual but perhaps unknown data values. So, if the input data variable is time, these are sometimes called time series graphs, showing changes over time. And so some questions you should be asking are there any patterns in the data? That's just a general question you should always be asking. And what kinds of patterns, what might we see? And so long-term trends, short-term trends, cycles in the data, maybe some other patterns. And then you might ask yourself, if you find some patterns, then what caused these patterns or changes in the data? Are these positive things or negative things? If they're negative, what can we do to reverse them? If they're positive, what can we do to encourage even more growth? So here's an example of a time series graph, and going back to the data that we've been going back to many times in these videos, we've talked about the ages of the United States presidents at their first inauguration, going from this one is a time series, and this is just the order they were inaugurated. So the very first president, George Washington, to the last one in this particular list, which is Barack Obama. And so, of course, this will go on in the future as we get more and more presidents. So, in a sense, this is still just a sample, even though it does include all data up to the time I'm recording this particular video. Now, the question you might ask is there some sort of trend here? And I don't know, it's kind of hard to see any particular trend here. But if these data had started high and went down, we would say, okay, well, over time, they're favoring younger people as president, or if it had been going the other way. Or maybe if you'd seen every time there's an older person, then there's a younger person the next time, so there's some reaction there. And we're not really quite seeing that. There's kind of a variety of different ages, and we'll see some. We see some right here at the beginning that are all pretty tightly packed in here in the upper 50s, lower 60s. But then, then we get an older person here, and then followed by a couple youngers, and we see some up and down for a while. Then in this period, it's a little bit younger here, but then. Then we get a lot more up and down here. So the oldest one is one of the more recent ones, Ronald Reagan, and George Herbert Walker Bush here. And Bill Clinton was one of the younger ones. And George W. Bush back here. Barack Obama's back younger again. And so we see, we see some up and downs. We'll see what happens, after this in the future. Not a lot of things I can really point out on here, but we do see some different things here. So you can see changes over time. One thing that's probably not quite as good about this one is these lines in between should kind of indicate data values, and these don't really indicate. There are really no lines in between. This is really discrete data here. So even though we could do a time series plot, it's not quite as good, and we can't really interpret points along these lines as being approximations of what's happening between these two, because there is no between those two. Now, another thing that we very often do is we compare two samples of data. So using we could use any type of descriptive statistics that we've talked about so far, whether that's numerical measures of center or variability or relative standing, or whether that's graphical representations such as dot plots and box and whiskers plots, histograms. But we can use those and compare two samples or two subsamples from a larger sample. For example, we could take the values that we did back here, and we might be interested in, say, Democrats versus Republicans. Does one party favor younger candidates in general than the other? That might be an interesting question. We might find out if that was actually true or not. Are there differences in salaries between men and women? If so, or between or for some particular minority group. If so, there might be a problem there that might need to be addressed if there's some bias. So what causes those things? And then the question then is, are any differences significant, or are they a result of natural random variation? And that's really one of the central questions about inferential statistics that we'll be getting into in our fourth and last unit in this course. So here is a set of box plots for these presidents at inauguration age, at their first inauguration, by party. Now, some of these are a little bit, not very useful. For example, the Unionists, there's only one candidate there, and the Whig Party, there's just a few there, and just a few of the Federalists, a few more of the Democratic Republican. But those of four are kind of small data sets, particularly Federalist, Unionist, and Whig. So that those really probably shouldn't even be done with a box plot. But we could certainly compare Democrats and Republicans here, for example, and see what we have. Well, we see Ronald Reagan up here is an outlier on the Republicans. But that's the only outlier that Minitab identified for me when I ran this through there. And you can see that the Republicans, not only do they have the outlier here, but the median's a little higher. Q3 in particular is a bit higher. So a lot of the really young presidents were over here in the Democrats, but the Republican has the youngest one. So Teddy Roosevelt over here. So you've got not a lot of difference, but the center is a little bit more packed in here. But then you've got the interquartile range is smaller and the Republicans, but then the range is actually bigger. So depending on how we measure variability, you might do some comparisons there. So you can do some comparisons there. Nothing real definitive and shocking in the difference of these two, but there are some differences that you can see. So it looks like in general Democrats are a little bit younger candidates than Republicans, but and Democrats. Well, the overall is, it's not too much different than the Republicans on the range, but the interquartile range is a little tighter there, smaller interquartile range on the Republicans there. So now what I want you to do is I'm going to give you a little project that I'd like you to work on. This is going to take a while. This is a pretty big project. But I think if you'll take the time to do this, you will make sure that you really understand these different descriptive statistics, because we're basically coming to the end of our first unit here. So I'd like you to go and get some data, and here's a place. I want you to go to Wikipedia and download the ages of Oscar winners for the best Oscar, best actor and best actress, their ages at the time they won the award. So this will be the Academy Award winners for Best Actor in a Leading Role and Academy Award winner for Best Actress in a Leading Role. And just because I want you to compare to some solution set that I've already worked up, let's go ahead and limit the data from the beginning of the award through the year 2015. In fact, even as I'm doing this video, it's already past that. But go ahead and take that ignore data since 2015 just for the purposes of sort of checking your work with my solution set. But then you might want to go back and actually include all of the data to whatever date you're watching this video. So anyway, here's what I'd like you to do. I'd like you to do dot plots for the two groups, for the actor and the actress. But use the same horizontal scale, and then I want you to line them up on the same piece of paper so they're using exactly the same axes. So you're going to have one dot plot below and then one dot plot above. So these will be two separate dot plots, but they'll be above, one will be above the other in such a way that they're using exactly the same scale. So in other words, if there's a dot for a 30-year-old best actor, then right above that will be the dot on a different graph will be the dot for dots for 30-year-old actresses, or you can put the actresses on the bottom, the actors on the top. I don't really care. Just be kind of consistent about it. And then I want you to make some grouped histograms. Let's do this in the lower 20s, 20 to 24, upper 20s, 25 to 29, lower 30s, upper 30s, so forth like that. Make an ogive. Again, on the grouped histograms, make two different histograms, again with the same horizontal scale, the same grouping in the bins, and do one above the other one. And then do ogive of the ages. Do these as two different, remember the ogives are cumulative relative frequency line graphs or broken line graphs. Put those on the same axes, so two ogives. Then make a table that has some descriptive statistics. First, give me some measures of center, the mean, median, mode, mid-range, and mid-quartile of the two groups. Then do some measures of variability, the range, interquartile range, mean absolute deviation, standard deviation, and variance. Then do quartiles, measures of relative standing. And then draw modified box plots. And again, use the same scale as before. And draw both of those using the same axes so you can compare them side by side. Then I want you to go back and look at everything that you've done so far and describe anything that you notice about the shape of the two distributions. And of course, you're going to need to identify any outliers, which will be part of your modified box plot. And then finally, when you're done, comment on any conclusions you can make when comparing the two data sets. And then what I'd like you to do is to combine all these results into a report that could be using either computer-generated graphs or graphs carefully drawn on graph paper, and try to create a little report, because I think this is an important little assignment, because if you can do an assignment like this and prepare a little report, that first of all, make sure you can find all these descriptive statistics. I'm asking you to interpret them so you know what they mean and can explain it and sort of use them to make a case if you see something that's important there to go forward. And then also present that in a nice presentation. And I think that's going to be very useful for you in the future. When you're finished with this, come back in the next video and I'll show you my report, and you can kind of see how yours might compare to mine.